Variance, an incredibly useful tool in stats. What is it? Well, why don't we ask the Australian curriculum? Okay, no, big help. Not to worry, this video is going to explain everything you need to know about variance in high school. Okay, let's start with two datasets about exam scores. A class of 5 gets 30, 40, 50, 60, and 70 out of 100, while another class of 5 gets 10, 20, 50, 80, and 90. Feel free to pause the video if you'd like, or you can trust me to say that the average of both datasets is 50. Here's the issue though, the average clearly doesn't tell the full story of either dataset. I mean, have a look at both datasets. The first one constantly increases by 10 each time, but the second one increases by 10, 30, 30 again, and then 10 again. So I think it's fair to say that although both classes have the same average, you could say that there is more variance among the second dataset. So I guess the question is, how can we mathematically define this variance? Well, to define variance, the data has to vary from something. A base point that can be used to show variance no matter how large or small the scores are. If we used a score of 0 as this base point, we wouldn't accurately define variance. Why? Because what if the class of 5 only got 100s? You can see there's absolutely no variance among the data points, but if our base point was 0, this dataset is supposed to have the highest variance. So we know 0 can't be our base point, and we also know it has to apply to all datasets. What about the average of the dataset itself? Because that way, the average changes according to the dataset, and it serves as a sort of middle ground that fairly shows how much variance there is. So if we go to apply this to our special case of 100 marks for each student, we get an average of 100. And as you can see, there is no data point that varies from the mean, which shows that there is 0 variance. So here's where variance starts to take shape. It's all about finding the distances from the mean to show how each point varies. Okay, so if we take the difference of each point from the mean, add them up, we should get an accurate measure of variance in the dataset, right? For the most part, yes. But there is still a slight issue with this. Say there was a class of 4 students, and 2 of them got 0 out of 100, and the other 2 got 100 out of 100. The mean is therefore 50, and so the distance between the first 2 points and the mean is -50 and -50, which is -100. Meanwhile, the sum of the last 2 variances gives us 100. So the total variance results in 0. Which we know isn't true. This is why in mathematics we square the distances of each data point from the mean to get a positive number no matter what when we find the variance. So this way, the two -50s get squared to get 2,500 each, as well as the positive 50s too. Since there's 4 of these, this adds up to a total variance of 10,000. And while this may sound like a huge number, just remember that all 4 points vary tremendously from the mean, and it's squared, so of course it's going to be a huge number. Finally, there's one more case to which our current definition of variance might fail, and it all has to do with outliers. So to eliminate this issue, we have to find a way of neutralizing outliers, which is done by taking the average of every single variance. And that is the final formula for variance. While it's definitely a clunky one, just know that there is a reason for each component of the formula. So from this formula, variance tells you, on average, how much each data point varies from the mean squared. That means if you square root the variance, you'll see on average how much each data point varies from the mean, which is what we call the standard deviation. Thanks for watching. If you found this video to be helpful, please be sure to like and subscribe. Also, if you have any questions or feedback, please let me know in the comment section down below.